And all right, and let's look at the practice quiz 2, quiz 4. Okay, you should have that on your screen, and um, you should just have the same old thing here that we had in the pad. If I need it to work problems, I will get some paper and we'll do that. Okay. Right. Practice quiz 4, Chem 1120. A certain process is carried out at constant pressure. The Q is found to be minus 2200 kilojoules. In other experiments, delta E is minus 21.90, minus 2190 kilojoules, and delta S is minus 350 joules per Kelvin. What's the value for the work for this process? So um, let's see, if I stop screen share, then you should see my pad. Okay, so let's look at the relationships that we have. Um, all right, we know that Q is equal to minus 2200 kilojoules. We know that delta E is equal to minus 2190 kilojoules, and delta S is equal to minus 350 joules per Kelvin. All right, so these are the data we have for the problem, and we want to know the work. Now, we need to think about the relationships. We've got work and Q and delta E. How are they related? Well, delta E is equal to Q plus W. Now, I want to make a point here that's kind of subtly made in the problem. It said that Q for a process that we're doing right now is minus 2200 kilojoules. In another experiment, delta E was found to be minus 2190 kilojoules. The subtle point is delta E is a state function. Delta E was minus 2190 in this other experiment, but delta E is minus 2190 in this experiment too, and delta E is minus 2190 in any other experiment that we might do. Delta E is a state function. Its value does not change unless you change the state of the system. And that we're not doing that. We're going to have all the same substances and all the same pressures and whatever that we had up here. So then delta E is Q plus W. So delta E is minus 2190 kilojoules. That's equal to Q, which is minus 2200 kilojoules, plus W. So my work, if I add 2200, I'm sorry, kilojoules to this and add 2200 kilojoules to this, plus W. This is going to cancel, and I just need to take the difference between these. So this is smaller, so I'm going to subtract it from this. So I'm going to get plus 10 kilojoules is equal to the work. And if we screen share to this, you can double check with me, and we did get the correct answer, plus 10 kilojoules. All right, now number 2. If we do number 2, we've got a reaction given. And now, number 2 says the reaction is 4NO2. It's gaseous. And we react that with O2 gaseous. And we're going to make 2N2O5 gaseous. And then we've got tables. We've got the delta H, and we've got a table here that's got the delta H of formation, the delta G of formation, and all of that. And it asks us for what is the partial pressure of NO2. I want the pressure of NO2 in the standard mixture. Oh boy, this is an easy one. What is the pressure of any substance in the reaction in the standard mixture? 1 atmosphere pressure. And so all we got to do then is check ourselves and be sure that we got the correct answer. And sure enough, there it is. 1 atmosphere pressure is the correct value. So, you know, I could have asked, what's the partial pressure of oxygen in the mixture? That would have been 1 atmosphere. I could have asked, what's the partial pressure of N2O5 at 1 atmosphere? That would have been also 1 atmosphere pressure. I could have asked for the same thing, the same kind of question. I could have said, well, what's the total pressure? Well, there's 1, 2, 3 moles of gas. Total pressure is 3 atmospheres. I could have asked at this point, the same question could have been, what's the mole fraction of each gas in the mixture? And that would be 1/3 for that one, 1/3 for that one, and 1/3 for that one. So there's lots of ways I can ask this concept question, and that's what it really is. We didn't have to do any math. It's just a concept question, and we could ask that in lots of different ways. Okay, so let's go on down and look at number 4. Let you get a glance at it. It really would be better if you have these things printed out, so that when we do this, and I have to close the screen where you can't see this while I work on the pad, it would work really good if you had a copy of the practice quiz to go over with me. Okay. All right, so let's look at the next one. We got to calculate delta H for this reaction, and it's the same reaction given in the first one. So let's do this. And so number 3 is 4 NO2s plus an O2 goes to 2N2O5. Now, I didn't put the subscript gases on them. It gets kind of messy on my pad, but they're all gaseous. And we're to calculate delta H superscript for this reaction. Well, the relationship is delta G superscript is the sum of the delta H of formation of products minus the sum of the delta H of formation of the reactants. So that's going to be, it's going to be 2 times the delta H of formation of N2O5 minus 4 times the delta H of formation of NO2. So that's going to be 2. Now, the delta H of formation of N2O5 is on the table. N2O5 is the bottom entry on the table. This is plus 11.30. Minus 4 times the delta H of formation of NO2, first column, first entry, is 31.18. These are all in kilojoules per mole, times the number of moles. So this answer is going to come out in kilojoules. So I want to take 2 times 11.3 minus 4 times 31.18. So if I do that, I get this answer is minus 102.12. And that's going to be kilojoules. Okay, so let's do the screen share so you can check with me. Be sure we got the right answer. Okay, yep, there it is. A is the correct answer. Now let's go down and do number 4. Number 4 is, again, the same reaction. And in some of these problems, you can use an answer that you got earlier. I'm going to give you the same equations to work with so that you don't constantly have to do the same calculation over and over again. I'm doing it so it will save you time on the test. But you really do need to be very careful, because if you miss one of those answers, the others that depend on it will be missed as well. So just be very, very careful if you're going back to use different data. If you want to recalculate it over again to check yourself, you can, but it might take a little more time than you want to do. All right, so let's I'll work the next one with you. It's going to, you can see it's the same reaction. Here's the same table of data, but this time we're calculating delta S for the reaction. Okay, so let's get you back so you can see my pad, and we'll set it up over here. We got the same reaction, so it's 4NO2, and O2 goes to 2N2O5, same reaction, and we want delta S equals what? Well, that mean old Dr. Pearson didn't give me the third law entropy values for them. So what am I to do? Okay, here's what I'm to do. Delta G superscript is equal to delta H superscript minus T delta S superscript. I can get this from the table. I can get this from the table. I know the temperature, so there's my delta S. So let's do some rearranging. I'm going to move the T delta S to the left side, so that'll make it positive. T delta S is equal to delta H minus delta G. Okay, now don't screw this up. Make sure that's right. And so delta S is going to be delta H minus delta G divided by T. Okay, now we just calculated delta H of the reaction up here. So I'm going to just bring that down. Delta S is delta H is minus 102.12. The temperature is 298.15 and minus delta G. Now, I don't think we've calculated that before, so let's do it down here. Delta G is equal to the delta G of formation of products. The product is N2O5. The value is the value in the bottom right-hand corner. So delta G for the reaction is going to be 2 times the value I see in my table. It's 115.1 minus the delta G of the reactants. It's 4 times that is the right-hand top column. And so it's 4. And the value from the table for the NO2 is 51.31. So let's do that math. So I get 2 times 115.1 minus 4 times 51.31. Okay, double check my numbers. 2 times 115.1 minus 4 times 51.31. Okay, we're getting delta G is equal to plus 24.96. And now it's in kilojoules, and delta H is in kilojoules, so I'm good. So my delta S is going to be, delta H is minus 102.1 minus plus 24.96. Now, and I want to divide that by 298.15 kelvins. So this is going to be in kilojoules per Kelvin. Okay. Now, I always do this because I want to be able to do this math, and I want to be sure I don't make that sign mistake right there. Now, if that had been a minus sign, that minus times this minus would have been plus for this term. But if I'm looking at this, this first term is negative and the second term is negative. So I'm going to get a negative number in my calculation up there. So let's do that math. And I'm going to do just what I'm showing right there on my calculator. I'm going to do the little minus down here, that minus 102.1. Now I want to subtract, that's that minus 24.96. And I need to evaluate that. So I'll do enter. And that comes out with minus 1047.06. I want to divide that by 298.15. And when I do that, I come up with delta S is minus 3.51. And there's a whole bunch of other digits, 3.5111118, and just a whole bunch of digits there. But this is now in kilojoules per Kelvin. I'm going to look at my answer. My answer is not in kilojoules per Kelvin. And I'm seeing a problem too right here. But let's see. So I want to multiply that by 1,000. And I get, I'm not getting one of the answers. Let me go back and double check my math and see what we've done. Okay, there's the reaction. That's correct. Delta S, delta G is delta H minus T delta S. I do think the sign of delta S is correct, because if I look back up here at the reaction, I've got 5 moles of gas going to 2. So that's a decrease. It's becoming more ordered. So the order of the product minus the order of the react, or disorder of the product minus the disorder of the reactant is going to be negative. So I think the sign's correct. So let's just double check our numbers. I think we did get that correct answer. So I'm guessing this is all right, but let's double check the math. Delta G is delta H minus T delta S. I take the minus T delta S over to this side. That becomes plus T delta S. The delta H stayed on the side it was on, but delta G moved across, so it's negative. So that looks right. So it's delta H minus delta G. So delta H was minus 102.12, and delta G we haven't calculated. The temperature, yes, is 298.15. So that number in that one looks right. Now let's double check down here. It could be that the answer is wrong up there, but all right. 2 times the delta H formation of N2O5, 2 times the delta H of formation of N2O5, that's right. And the delta H of formation of N2O5 is 115.1. So I've confirmed that, and that is correct. There are 4 NO2s, and so it's 4. So it's minus product minus reactants minus 4. That's correct. And the value is 51.31. Now let's just double check this math and see if I got it right. 2 times 115.1 minus 4 times 51.31. I did get plus 24.96. So it's delta S was delta H. Oh, wait a minute. Yeah, that is correct. Delta H, it was plus the value of delta H. That's right. The value of delta H was minus 102.1 minus delta G, which is a plus 24.96. That looks right. All right, so let's do the math again. So I get minus 102.1 minus 24.96 and divide that by 298.15. Yeah, I just screwed up in entering the numbers right here. What I'm coming out this time is, I'll put it over here. Delta S is minus 0.426. Okay, and then I need to multiply that by 1,000. And I get minus 426.2. And of course, joules per Kelvin is the correct answer. All right. That feels a little better. Let's go to screen share. And And there's that. Now, you know, I always, when I'm working problems for you guys, I always want you to see the thought processes that I go through. And that means that I've got to work these things cold. And I make mistakes on calculators just like you do. And the reason why I knew that answer was not correct a while ago was I didn't find it over here. And I'm pretty confident when I make out exams and quizzes that I put the right answer on there. Sometimes I make a mistake, but most of the time I'm going to have the right answer to plus or minus 1 in the least significant digit. So if you don't get the answer I do, there's probably something wrong. Okay? So, all right, now, um, we're ready to do number 5 on the test, and it's again the same reaction. This time we're calculating Kp from the same set of data. So let's now stop the screen share and get back over to the pad again. Ready to do number 5. And if any of you have something else coming up, our class officially ended about 3 minutes ago. So if you have to go, that's okay. I'll see you on Friday, and let me know by email if you have any questions or anything before the quiz comes up Friday. All right, so this one, we're going to have the same reaction. It's 4 NO2s, and O2 goes to 2 N2O5. Okay, so that's our reaction. And we want to calculate Kp. All right. So now let's go ahead with it. Then I need the relationship. I need delta G superscript is minus RT ln of Kp. So again, analyze the problem, put the relationship in, plug in what you know, and solve for what you can. Now, I need to get to Kp. I know R, I know T, I need delta G superscript. Now, we just calculated that a while ago, and we got delta G superscript. We got it to be plus 24.96 kilojoules. That's equal to minus 8.314 joules per mole per Kelvin times 298.15 times the ln of Kp. Okay, so ln of Kp I can solve for now, but let's do the math. I'm going to take the 24 plus 24.96 times 10 to the third joules plus, moving this across, plus 8 point, no, I'm sorry. That would have been bad. I got to divide by that. Okay, all right, so we're going to divide by minus 8.314, and that's going to be in joules per mole, and times 298.15 is equal to the ln of Kp. So delta G is going to be this value divided by negative RT, and that'll be equal ln of Kp. Looks good, so let's do the math. So we get 24.96 with an exponent of 3, divide by the minus sign is this one down here, minus, down that one, minus 8.314 and divide by 298.15. So I'm coming out with the ln of Kp to be minus 10.0693, a whole bunch of digits, raise e to that power, and I get Kp is equal to e to the minus 10.0 digits. And if I say second e to that answer, I get Kp equals 4.2359, some more of the digits, times 10 to the minus fifth. Okay, all right. So let's see if we were successful with that one. So here we are. Now, be familiar with this. In order to avoid subscripts and superscripts in the answer that technically are difficult to do in my test generator. So in this quiz, I have written the numbers like you would write them on your calculator. 4.2 EE minus 0.5 is the way you enter that number in your calculator. So when you see this on the quiz, that's what it means. This EE is times 10 to the minus 0.5. That's what that EE stands for. 4.2 times 10 to the minus 0.5. Okay, that's the correct answer. Let's do number 6. Okay, so number 6, again, we've got the same reaction taking place. So let's get this one so we can solve it. And need to stop sharing here and go back over here. Now, we're given the same reaction. If you want to increase the concentration of N2O5, now, so my reaction is 4, this is number 6, it's 4 NO2s, and O2 goes to 2 N2O5. And I want to increase the concentration or partial pressure of N2O5. If I want to increase that concentration from the standard state, then I want this reaction to shift to the right past the standard state. And that's the direction I want it to go. Now, we want to know, what do we do to T? Does it go up or down? And what do we do to P? Do we raise the pressure up or down? Now, this one will be easier to do if we do it first. Increasing pressure by Le Chatelier's principle. Increasing the pressure causes it to shift to fewer moles of gas. Now, in my reaction, on the reactant side, I've got 5 moles of gas. And on my product side, I've got 2 moles of gas. So if I increase the pressure, it's going to increasing pressure is going to cause a right shift. So that's what I want. And I could look over there and I could eliminate A and D right now because they had decreasing pressure. And what about the temperature? Well, The temperature effect is from delta H sine. The sine of delta H. If delta H is less than 0, heat is a product. Means heat is coming off. If heat is a product, then increasing temperature would shift left. Because if heat is a product and I add more heat, it's going to go to use up the heat. So I need the sine of the delta H. And somewhere we calculated that. We calculated delta H for this reaction. Delta H was minus 102.12 kilojoules. So minus means heat is a product. If heat is a product, it shifts left. We want it a right shift. So if I increase the temperature, it shifts left. I want to decrease the temperature, so it will shift toward the right. So I want to increase pressure and decrease temperature. And that logically should be the correct answer. And there it is. We would increase pressure and decrease the temperature to make this one happen the way we want it. Now remember, don't just memorize these answers, because they change with the sign of the delta H, and they're going to change with the number of moles, and they change for which one I'm asking for. I mean, I ask you, suppose you wanted this concentration to increase. Well, what if I'd said, I want this one to increase? Well, then everything would be reversed. So read the question carefully, see what it's asking for, and then all of those possibilities, and there's, I guess, 8 of them altogether, will be the same problem then. Okay, now we're ready to do number 7 on here. And so number 7 is, we got the same table, calculate delta G for a different mixture. So 4 atmospheres of NO2, 1 atmosphere of O2, and 2 atmospheres of NO2. So let's get back where you can see my pad, and maybe I'll have room down here to work it. Okay, so here we go. My reaction is still 4 NO2s. Everything's still gaseous. O2. The reaction is going to be 2N2O5. And I want to calculate delta G at the pressure of NO2 equal 4 atmospheres. The pressure of O2 is equal to 1 atmosphere. And the pressure of N2O5 equals 2 atmospheres. Now we could have any values we wanted to, but I thought it would be kind of cute and interesting if we used the partial pressure the same as the balancing coefficients. And let's just see what happens. So delta G is equal to delta G superscript plus RT ln of Q. Now let's calculate Q. Q is going to be the pressure of the N2O5 squared, coefficient is 2, divided by the pressure of NO2, and that's to the 4th power, and the pressure of O2, and that's to the 1st power. So now that's my value of Q. Well, we can put the numbers in. The pressure of N2O5 was 2 atmospheres. So that's going to be 2 atmospheres squared the pressure of the NO2, pressure of NO2 was 4 atmospheres, and that's raised to the 4th power. And the pressure of the O2 was 1 atmosphere raised to the 1st power. Okay, so I can do that math, can I? I can take 2 squared, and divide by 4 raised to the 4th power. Divide by 1 to the 1st power doesn't do anything. So what I'm coming out with my Q is equal to 0.0152625. Okay, so there's my Q value. That goes in right there. Now my delta G, we did calculate that somewhere. Yeah, the delta G superscript. We got to be 24.96 kilojoules, 24.96 kilojoules. So we got all the data we need to plug in to get our answer. I'm going to just slide this up as much as I can, slide another page in here. We get delta G copying this, delta G superscript we just calculated is plus 24.96 times 10 to the 3rd joules. I'm anticipating the value of R over here, plus 8.314 times 298.15 times Q. Now Q is my answer on the calculator. So I'm going to just do this math and see what we get. So the delta G is equal to 24.96 with an exponent of 3, that's times 10 to the 3rd, plus 8.314 times 298.15 times the ln of Q. I left off the ln. Okay, times the ln is this function of my second answer, my answer. I still got on my screen. So you probably can't see my screen. Maybe if you can blow it up, you can. But that's the data. And if I plug the number in, I get 1450.8818 joules. I want to divide by 1,000 to get it into kilojoules. So I get right there, I get 14.650 kilojoules. And I think that ought to be the answer. So let's look back at it and see that we did get the correct answer. So we got plus 14.6 kilojoules. I guess technically I probably should have rounded that to 14.7 since my drop factor was actually had some digits out there at the end. That meant I was dropping something a little greater than 50. So technically the answer should be 14.7. But, you know, I always have told you your answer should agree with mine to plus or minus 1 in this last significant digit that's shown. And that would still fit. Okay. Now that completes the practice quiz. I'm going to stop recording now.